Hi and welcome back to Gaffy's Grinds. This is video 9 in our series on particles for junior cycle science. So in these short videos, we take concepts from junior cycle science, we break them down, we help you understand them in small, manageable chunks, and then we give you some practice to do. Okay. Some tips for using these videos are make sure that you eliminate all distractions, like make sure you put your phone in another room or turn it off, and make sure you close any other tabs you've got open on your computer. We don't want to overload our working memory with distractions. If we do that, our working memory is too small to be able to process the distractions as well as the new information that you're trying to learn here, okay? The other thing, the most important thing, is that any practice exercises or questions that I get you to do, it's really important that you think really hard about them and you give them your full attention and try your absolute best to do the questions. If you do that, I promise you, you'll learn lots of stuff. But if you don't, you're pretty much wasting your time here, okay? So in today's lesson, this is video 9. Remember, I always say, this is a really good place to learn about junior cycle science, but if you don't watch the videos in order, this video is not going to make as much sense. So it's a good idea to go back and watch videos 1 to 8 before you start here. In today's lesson, we're going to be learning about mixtures. We're going to be learning about mixtures and what a mixture is. Okay, so I'm going to start off by drawing, okay? So we're going to take a substance called air. Air. This is a substance that we're familiar with. Air is a mixture of gases that we breathe every day. Now, what is air composed of? What is it made up of? Well, first of all, we've got different gases in here. So the first gas we're talking about is oxygen. And oxygen looks like this, 2 oxygen atoms, which are chemically combined, okay? So this here, these atoms touching, shows that these are chemically combined. The 2 oxygen atoms are chemically combined. So this is oxygen, chemically combined 2 atoms. Another gas that we have in here is C with 2 O's. C atom with 2 oxygen atoms. This is called carbon dioxide. So this is another gas that we find in air. Another gas we find in air is made up of 2 nitrogen atoms chemically combined, touching each other like this. Okay, so 2 atoms of nitrogen which are chemically combined. This is nitrogen gas. And I'm just going to draw a couple of them. So we've got a couple of nitrogen gases and a couple of oxygen gases and some carbon dioxide. Okay. Actually, do you know what? I'm only going to draw 1 oxygen and I'm going to draw another nitrogen. Now, the reason why I chose to draw 3 nitrogens is because, believe it or not, most of the air is nitrogen. Most of the air is nitrogen. Some of the air is oxygen, and a very small amount of the air is carbon dioxide. Now, so this is air. It's a mixture of these gases. Where the atoms are shown touching each other, like I've drawn for the oxygen here, that means that those atoms are chemically combined. But the thing about it is that the different gases here, so for example, the nitrogen and the oxygen gas, I'm drawing an arrow into the space between the nitrogen and the oxygen gas. And then the nitrogen and the carbon dioxide gas, I'm drawing another arrow into the space between the nitrogen and the carbon dioxide gas. Hopefully, you can understand that there are no chemical bonds between these different substances. There are no chemical bonds between these different substances. So these gases, oxygen and nitrogen, are not chemically bonded to each other. They are not chemically combined, or they are not chemically bonded to each other. The nitrogen and the carbon dioxide, these 2 particles over here, they are not chemically combined to each other. So air is a mixture of these different gases, and these different gases are not chemically combined to each other. I'm going to take another example. Say we have salt plus, we've got salt sand and water. And we're going to mix them together. Now, the salt I'm going to show as a black triangle. So I'm going to shade it all in black. Salt is made of salt particles. That's one type of particles, one type of substance. Plus, I'm adding to it. I'm going to draw this one in green. The sand I'm going to draw in green. So this is my sand. This is a different substance made of different types of particles. So it's a second substance. It's different particles to the sand. And my water, I'm going to draw in. So water plus, I'm going to draw a container, and the container has water. It's another substance, H2O. So I've got salt, I've got sand, and I've got water. And I'm going to mix them together. So I'm mixing them together and put them into the container. I'm going to put the sand and the salt into the container. And what is the result? Well, I still have my water. That substance is still there. Those water particles are still there. H2O. Oh, didn't want that to happen now. Yeah, there we go. Okay, so this is H2O. So I still have my water. Now, my sand, which is green, this substance is going to mix with the water, but eventually it's probably going to settle to the bottom. So the particles of sand settle on the bottom. So the sand settles to the bottom. And we've learned in the previous lesson what's going to happen to the salt. So on 3, tell me what's going to happen to the salt. I'm hoping that you said the salt, we can't see the particles here because the salt has dissolved. Has dissolved. The key thing though here, and I want to get across, is that we have different substances, the sand and the water and the salt, different substances. We've got 3 different types of particles in there, and they have not chemically combined. So any substance which contains different substances which are not chemically combined, that is what we call a mixture. So mixtures, we're going to define what a mixture is now. A mixture is where we have different substances. Jeez, that's annoying. Different substances which are not chemically combined. Different substances which are not chemically combined. These are mixtures. Okay, so let's highlight what's really important here. We've got different substances. So for example, in our air, our different substances were nitrogen is one substance, oxygen is another substance, carbon dioxide is another substance, which are not chemically combined. So not chemically combined. So this shows in here, this space, they are not chemically combined. So if they were chemically combined, we would draw them touching each other, or we would have a bond linking them like that. Sometimes it can be shown like that. And we do not have those here. We have spaces or gaps. That means that particles are not chemically combined. Let's check the other mixture now. We've got different substances, salt sand, and water. Here they are here, salt, sand, and water, and they are not chemically combined. They are still separate. The sand actually sits down at the bottom by itself. It's actually quite easy to separate this. You could just pour off the water. So you have not made a new substance. So that's a key reason you would know if you have a mixture. You have not made a new substance. Okay, so you have not made a substance here that would be called salt, sand, water, or sandy salt water or something like that. You would call it salt and sand and water. Salt, sand, and water. These are a mixture. They are not a new substance. Okay, so mixtures, different substances which are not chemically combined. So the not chemically combined thing, that's the key here. That's how you understand that it's a mixture. If the two substances did chemically combine and made a completely new substance, so say for example, we mixed carbon, a carbon atom, and we had pure carbon, and we decided, okay, we're going to burn our carbon. We're going to burn it and catch fire to it. Well, for carbon to burn, it needs oxygen present. So what would happen here is the carbon would then be attached to two oxygen atoms. Sorry, that should be touching. So because the carbon is now actually physically attached or chemically attached to the two oxygen atoms, this is now a new substance which is called carbon dioxide. It's a new substance. It's not just carbon anymore. And these have chemically combined. So chemically combined. This would not be a mixture because the substances have chemically combined. In these two examples we looked at earlier, the different substances are not chemically combined. Okay, so time for you guys to do some practice now. Actually, before we do that, what I want you to do is I want you to pause the video and I want you to take down the definition of a mixture. So it's up here at the top of the screen. Mixture is different substances which are not chemically combined. So pause the video and take that down. Okay, so you should be watching the video if you have paused the video and taken down the definition of a mixture. You should also write that it does not make a new substance. Okay, now I've just spelled that wrong. That should say do not make a new substance. Okay, so we do not make a new substance. And some examples of mixtures then are air, and then salt water, and sand and water. Any of those solutions that we looked at earlier, as you can see, salt and water makes a solution that is a mixture. It's not a new substance. Okay. Other things can be mixtures like different mixtures of sweets. We call, wine gums are a mixture of sweets of different colors. They are not chemically combined. What else? Gases like air, and air is a mixture of gases. Yeah, I think if you've got a couple of those, you're doing okay anyway. Okay, so it's time to do some practice now. Okay, the first thing I want you to do is I want you to, I'm just gonna have to pause the screen here for 1 second to fix this first. Okay, so what I want you to do, in a minute, I'm gonna ask you to pause the video. When I do this, what I want you to do is I want you to complete this paragraph by filling in the blanks. Now, I don't want you to just write what the blank words are. This is practice for you to practice your scientific writing. So you need to practice writing the whole paragraph. So I want you to pause the video and write out the full paragraph, but fill in the key words. Okay, so pause the video and do that now, please. Okay, so you should only be watching the video if you have paused the video and you have given your best attempt at filling in the keywords. The answers are coming up now. So these are the answers. Pause the video to make any corrections. Okay, well done if you got that right. I hope you did. I hope it was pretty straightforward. Okay, and we're going to do some practice questions now. The questions are coming up. So here they are. Questions 1 to 4. I want to pause the video and write down the answers to these questions. Okay, so you should only be watching the video now if you have paused the video and had a go at writing down those questions. Okay, I'm hoping that you, I forgot to tell you, but I have told you before, you're always trying to do these questions from memory, not from the notes that you've taken down. So you should cover up the notes when you're doing the questions. Okay, it's practice to see if you can retrieve things rather than just copying from what you've taken down. Okay, so the answers are coming up now. And there are the answers. Pause the video now to make any corrections to your answers. Okay, well done. If you got those right, then you're pretty sure that you understand what a mixture is. I hope you found this video useful, and we will see you in the next video.